In this lecture, I'm going to attempt to explain the idea of convolution through an example. And the example takes after my great-great-grandfather, Dr. Hobart Knospe, who left his job as a university professor to become a farmer. Unfortunately, this was a sad tale, and the whole enterprise ended in financial ruin. Hobart had learned of the exciting opportunities to make money in Missouri growing hams. Ham farming is very difficult farming. The plants are short-lived, and they produce very few hams per year. And so after a few years, Hobart's fields were barren, and his life savings were gone. Let's now learn a little bit more about ham farming and this sad tale. Let's suppose you plant one ham seed, and the ham seed germinates and a strong vine grows. You carefully water it. After 1 year, your plant will produce only one ham. In the second year, it will produce 3 hams, so you'll be feeling better about your farming. But in the third year, it will produce only 2 hams. The first 3 years are the only productive years in a ham plant's life. In the 4th year, the ham plant produces no hams at all, and in the 5th year, the ham plant dies. So you can see that ham farming is a very tough business. Let's again review the life history of the ham plant. If we plant a seed, in the first year the plant will produce 1 ham. In the second year it will produce 3. In the third year it will produce 2. In the 4th year it won't produce any hams at all. And by the 5th year it has died. This history of the number of hams produced from one seed is a signal. It's a signal in discrete time. It's discrete time because time doesn't take on values over the entire range of reals. It takes on only integer values, 0, 1, 2, 3, and so on. Here is another signal. This is the number of seeds planted by Hobart each year. In 1899, he started up the ham farming business. He didn't plant any seeds, he just tilled his field. In 1900, he planted 1 seed, and in 1901, he planted 2. In 1902, he was feeling rather ill, and so didn't plant any seeds at all. And in 1903, he planted only 1. After that, he was rather busy and didn't plant any seeds at all. So let's now look at the number of hams that were produced each year from Hobart's farm. Recall that he planted 1 seed in 1900, 2 seeds in 1901, and 1 seed in 1903. From this, how can we determine how many hams were produced each year? First, let's look at the 1 seed planted in 1900. It produces no hams in 1900, 1 ham in 1901, 3 hams in 1902, 2 hams in 1903, and none in 1904 or 1905 and after. For the 2 seeds planted in 1901, we'll get the exact same signal, except we'll get it twice, 1 for one plant and 1 for the other. And this would start in 1901 rather than in 1900. For the 1 seed planted in 1903, we need to show this signal only once, and starting in 1903. Therefore, 1 ham is produced from this plant in 1904, 3 in 1905, 2 in 1906. So totaling up the production from all the plants, we find that the farm produced 1 ham in 1901, 5 hams in 1902, 8 hams in 1903, 5 hams in 1904, 3 hams in 1905, 2 hams in 1906, and no hams in 1907. The number of hams produced by the farm each year is a signal too. It's a discrete time signal like the other two we discussed. This signal is formed from the other signals. It's formed from the number of seeds planted each year and the number of hams each year per seed. You can think of the number of hams produced by the farm each year as the output signal of the farm system, and the number of seeds planted each year as the input. So we've taken our input signal, the number of seeds planted each year, and we've operated on it with another signal. Our second signal is the time history of hams produced from one seed. From these two signals, we've generated a third signal, the output signal, the time history of hams each year resulting from the seeds that were planted. I've shown you one way to calculate the total number of hams produced each year by the farm. But now I want to show you another way of calculating this output signal. And this other way is based upon discrete time convolution. You've been learning about convolution in the continuous time, but in discrete time it might be a bit easier for you to understand. This discrete time convolution takes the two signals, the input signal and the signal that represents the system, which is the number of hams produced from one seed. And from these two signals, it generates a third signal, the output signal. Let's look more closely how discrete time convolution works. First, we'll flip the number of hams from one seed signal. We flip it about the start of year 0. Year 0 is the year that the ham seed is planted. We'll place this time reverse signal along with the number of seeds planted each year signal, and we'll place it in such a way that the index marker on the time reverse signal will indicate the year of interest. So for example, in the figure shown, we are trying to figure out how many hams are produced by the farm in the year 1901. It's convenient to represent the two signals, the time reverse signal in pink and the number of seeds planted each year in green, to represent these two signals along different planes. Represented here is the situation for these two signals if we're trying to determine how many hams were produced by the farm in the year 1900. To determine that number, we simply need to multiply the pairs of corresponding numbers together and add them up. So we multiply 0 times 2 plus 0 times 3 plus 0 times 1 plus 1 times 0 plus 2 times 0 plus 0 times 0, and so on. For the year 1900, this multiplying pairs and adding up produces 0. So there are no hams produced by the farm in the year 1900. To determine the output signal for the next year, 1901, we simply need to slide the time reverse signal forward so as to bring the index marker to 1901. Then we do the exact same operations before. We multiply the pairs and we add them up. So in this case, it's 0 times 0 plus 0 times 2 plus 0 times 3 plus 1 times 1 plus 2 times 0 plus 0 times 0 plus 1 times 0, and so on. When we add it up, we'll find out that this produces the value 1. That means the farm produced 1 ham in the year 1901. So then, to find out how many hams were produced in 1902, we carry the process out again. We slide the time reverse signal forward, and then we multiply the pairs and add. Multiplying the pairs, we find 0 times 0 plus 0 times 0 plus 0 times 2 plus 1 times 3 plus 2 times 1 plus 0 times 0 plus 1 times 0, and so on. And that value is equal to 5. So 5 hams were produced in 1902. We can keep this process up to find the number of hams produced by the farm in each of the succeeding years. For 1903, we find the value 8. For 1904, 5, and for 1905, 3. If you think carefully about it, it's fairly easy to see why this works. Let's consider the year 1902. Now, any plants planted in 1902 do not produce any hams. The 2 seeds that were planted in 1901 are now 1-year-old plants. And 1-year-old plants produce 1 ham each. And therefore 2 times that 1 means you'll get 2 hams out of those 1-year-old plants. This same year, the 1 seed that you planted in 1900 is now a 2-year-old plant. And we know that 2-year-old plants produce 3 hams each. And therefore this plant, planted in 1900, produces 3 hams. So in total, we find we get 2 times 1 for the plants that are 1 year old, and 1 times 3 for the plants that are 2 years old. So a total of 5 hams for 1902. I hope that this example shows you why convolution works, why we time reverse the signal that is associated with the system and then slide it across the signal associated with the input, multiplying these two together and then adding up. In the case of continuous time convolution, the adding up is done by an integral. After the failure of his ham crop in 1907, Hobart was ruined. He had nothing left. He sold the farm just to pay off his debts. He moved from one place to another, unsure of what to do next, until he landed in the Yukon Territory and found once again the thrill of standing before an audience and amazing them. It was just like being back in the classroom.
I'm going where the chilly wind never